right, section 10.6 is about factoring, which it's similar to what we did in 10.5, but if we look back at 10.5, we will notice that our problems in 10.5 never had a coefficient for x squared. In fact, this a was missing completely from the title of our section. And so in this case, we're going to have a number in front of x squared, and let me tell you, it makes all the difference. So we're going to have to learn a strategy that will help us factor here. Now, just like we did in 10.5, which if you need to go back and look at that video, I'm sure it'll be hanging out somewhere around the YouTube page, or maybe I'll put it to where it shows up at the end of the video. So just like we did then, if we think about multiplication here, we can kind of work backwards and figure out how this is all going to work. So the method to multiply two binomials together is FOIL, or you can use the distributive property. Either way, we want to do 2x times 3x, which is 6x squared. We want to do 2x times negative 5, which is negative 10x. We want to do 3 times 3x, which is 9x. And we want to do 3 times negative 5, which is negative 15. We add the middle terms together and get 6x squared minus 1x minus 15. So our problems today are going to start off looking like this, and our goal is to try to write them like this. Now, we should be able to see, since we have the answer in front of us, that the 2x and the 3x are coming from the 6x squared, and that the 3 and the negative 5 come from the negative 15. The thing that is hard about this, the thing that makes this more challenging, is that the negative x is not obvious how it's affecting what we have. In order for this to actually work, being able to do the outer and inner terms together is supposed to give us a negative 1x. And so, as we'll see in a moment, the question becomes, if we start with something like this, how do I know how to split up each of these things? How do I know that it's 2x and 3x instead of 1x and 6x? How do I know that the negative 15 should split up into 3 and negative 5 instead of 1 and negative 15? So that's what we'll explore in a moment. There's multiple ways to do this. This is not the same as like how there's multiple ways to solve a quadratic equation. Like in that situation, there's usually a best way to pick to solve it. In this case, what I mean by multiple ways is kind of like how we can FOIL or distribute. It's doing the same thing, but a different thought process. There are different methods for this, but all of them are fairly equal, aside from this first method, guess and check. So the idea behind guessing and checking is that you look at the trinomial you're given, and you write down your two parentheses, and you know that in the first spot of each should go what multiplies together to get 2x squared, which has to be 2x and x. Now, those could go in the opposite order. You could put the x first and the 2x second. And then in the second spot in each parentheses has to go what multiplies to get a positive 1. Since there's only one choice for that, this is a really easy problem that I have to put a plus 1 and a plus 1. Now, I only had really one option for what to pick here. If I had more than one option, I would have to do the check part of guess and check, which is to say, what is this multiplied together plus this multiplied together? So 2x times 1 is 2x, and 1 times x is 1x. If I add those together, do I really get 3x? Since I do, I know that this was the right answer. So let me give you a for instance of why that's not always a super helpful way of doing things. So here is an example, 18x squared plus 57x minus 208, that I purposefully picked bigger numbers. And actually, I picked bigger numbers than we probably would encounter. Just I wanted to really drive this point home, why guess and check is a flawed method. If I want to guess and check on this, I need to split the 18x squared up. So wait, I can do 2 and 9, 2x and 9x. Or I could do 3x and 6x. Or I could do x and 18x. Or I could have them flipped around. and have like the 9x first or the 6x first or the 18x first. So already that's 3 or 6 different scenarios that might be the case. Then what about 208? How am I going to split 208 up? Because 208 could be 1 and 208, could be 2 and 104, could be 4 and 52. I could have actually picked a worse number because like 3 doesn't go into this and 5 doesn't go into this. And so we're going to be limited kind of on what we can do. Does 8 go into it? Yeah, 16 times. And so we've got quite a list going already. Does anything else go into it other than that? That might be it. I think that is it, because the next thing to try that might work would be 16, but we already used that. So what happened, like how do I figure out, should I put +1? Oh, one of them has to be negative. Should I put +1 and negative 208? Or should I put -1 and positive 208? Or let's just face it, probably the 208's not going to work out. So how do I decide which of these works? Should I do +8 and -16? Well, I'm going to have to FOIL this out almost. I'm going to have to do 3x times -16 and 8 times 6x and see if that adds together to get 57x. I'm going to have to do that for every single situation I have. So guess and check is a great method some of the time and is a terrible method some of the time. So the rest of this video, I'm going to show you an alternative method. I actually know of 3 different ways to do this alternative method, that in every single one of them you are doing basically the same thing, you're just thinking of it a different way. And so this is the method I think might be easiest to understand. Let's do this one, because I mean I have a hard time picking which one's my favorite, but I'm leaning maybe it's this one. I don't know. So it says factor the trinomial if possible. If it can't be factored, write not factorable. So it may be that in this section of your book, they may actually try to trick you because maybe some of them can't be factored at all, which means that when it comes down to it, there's not a scenario where you could multiply out your parentheses and get this original problem. So we are going to use the box method. To use the box method, you start by multiplying the outside numbers 3 and 8 together. 3 times 8 is 24. Okay, we're going to use that in a second. Actually, I guess our first step is to make a box, because this is the box method. This box is supposed to look like a Punnett square, if you've done a Punnett square before in your science class for assigning genes and things like that. So in the top left spot of the box is going to go the 3x squared. And in the bottom right of the box is going to go the 8. And in the other 2 boxes, we're going to put something that adds to get 14x. And so since it adds to get 14x, there's going to be an x in both of these spots. Now, the numbers we pick are going to be what multiplies to get 24, that adds to get 14. So that's a little bit different than what we did whenever our leading coefficient was just 1. Okay, we have to do 3 times 8 and get 24, and then we're saying, okay, what multiplies to get 24 that adds to get 14? So our choices for 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Which of these adds to get 14? It'd be the 2 and the 12. So I'm going to put 2x and 12x. It doesn't matter which one you put where, it just matters that they're in the diagonal. So in order to figure out what our parentheses should look like, we're going to use this box and we're going to use the columns and rows here, and we're going to find what they have in common. So for instance, I'm going to look at 3x squared and 2x, which is this part. Oh no, I can't even see that. Here. We're going to look at just this part of our box. I'm going to say, what do they have in common? What do 3x squared and 2x have in common? And then whenever I know what they have in common, I'm going to write that over on the left side. I have a better idea. I'm going to say, what do these have in common? I'm going to write it over here. So they just only have an x in common. So I'm going to write down an x right here. And then I'm going to look at the 12x and the 8, and I'm going to say, well, what do 12x and 8 have in common? What can I divide both of those by? What's the biggest thing I can divide both of them by, which would be 4. Now I'm going to do the same thing, but I'm going to do it up and down. I'm going to do the column. So I'm going to look at this part right here. That was a terrible idea. I'm going to say what goes into 3x squared and 12x. And whatever that is, I'm going to put it up above. So they are both divisible by 3. They both have an x, so I'm going to write an x right here. I'm going to look at the 2x and the 8, and I'm going to say, well, they're both divisible by 2. If all of these are positive, then we should put a plus sign here and a plus sign here. And these two sides have given us our parentheses. One of our parentheses is going to be 3x plus 2. And the other is going to be the left side, which is x plus 4. I feel like that took a while and took a lot of effort. And as you work through it, as we do more of them, it should go faster and seem quicker. It's not as fast as... Some of the time, it's not as fast as guess and check. Maybe it was really easy to realize that we needed to put 3x and x, and maybe you pretty quickly realized that you needed a 2 and a 4 and which one to put where. But for a lot of us, it would be easier just to work through this box method instead. Well, let's do some more just so that we can make sure that we understand how this is all working out. So the box method, I'm going to draw a box. And in the top left, I'm going to put the 2a squared. And in the bottom right, I'm going to put the negative 12. In the diagonal, I'm going to put, let's see, 2 times negative 12 is negative 24. I need what multiplies to get negative 24, that adds to get negative 5. So I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, there's only one of those that subtracts to get 5, and so I just need to decide, do I want to make the 3 negative or the 8 negative if I want to add and get a negative number? And so since I want the bigger number to be negative to add to get a negative number, that means the 8 needs to be negative. So in one of the boxes, I need to put 3a, and in the other, I need to put negative 8a. So now I'm going to look at my rows. 2a squared and 3a both have an a in common and not a number. Negative 8a and negative 12a have a negative in common that I'm going to take out. And more importantly, our rule is going to be if the first part of what we have, so if this is negative, if our a is negative, I'm going to take a negative out. And then the number they have in common is a 4. Now I'm going to look at my columns. 2a squared minus 8a. I'm not going to write down negative because my initial thing up here, yeah, my top part is not negative. So if either if the left side, if I'm trying to fill this in, is negative, or if the top, if I'm trying to fill in the top, is negative, that's when I take out a negative. Otherwise, I'm going to leave out the negative completely. So this is going to be a 2a that they have in common. This is going to be a 3, and it's not negative because 3a is positive. The top is positive. So this is going to be 2a plus 3, and then times a minus 4. Now we can pretty quickly double check that we've got the right thing because 2a and a should multiply to give me 2a squared. 3 and negative 4 should multiply to give me negative 12. And if I do 2a times negative 4 plus 3 times a, that should give me negative 5a. And so we should see that's our answer. And so doing that is going to help us if we're worried about our signs. Really, we should just have to do a lot of the times we should just have to do part of that to make sure that we are correct, but it never hurts to go ahead and work through the whole thing to make sure you have all the right numbers. Example 3. So let's make our box. I decided apparently to make a big box. In the top left is 6x squared, in the bottom right is -6, and in the other two we need to do 6 times -6, the first one times the last one, and then think what multiplies to get -36 that adds to get -5. Let's see. Really, for a lot of people, and I totally get it, this is the most difficult part, is coming up with which pair works. And so if you are struggling because you think 6 times 6 and that's all you can think of, you have to be able to come up with other things that go into it. And so either that means going over your multiplication tables so that you're better at thinking of them, or maybe it just means being really systematic like I am, going through each number and really thinking about whether or not it goes into it. In this case, 4 and 9 is what works, and since we want a -5, the bigger number needs to be negative. So -9x and +4x. It doesn't matter which number you put in which part of the diagonal. If I were to switch these around, then it would switch my two sides, like what my answers would be, but I would still get the same answer overall. So 6x squared and -9x have a 3x in common. I'm not going to take a negative out because the left part of my box is not negative. 4x and -6 have a 2 in common, and that's going to be positive as well because this is a positive. Looking up and down, 6x squared and 4x has a 2x in common. And then -9x and -6 have a 3 in common, and they also have a negative in common. Perhaps an even easier way to check here is 3x times 2x should give us 6x squared. 3x times -3 should give us -9x. 2 times 2x should give us 4x, and 2 times -3 should give us -6. So that's actually even easier, I think, to check it that way than to check it once it's written down. One of our parentheses should be 2x minus 3, and the other should be 3x plus 2. You can write it the other way around, or if you had switched the diagonal, you would get it the other way around. Like, it doesn't matter which of these two you write, as long as you have the correct signs and in the correct place, and you have the correct, the numbers in the right order. As in, like, 2x minus 3 can't be replaced with 2x plus 3 or 3x minus 2. All right, so at this point, it's really about making sure that you've got the hang of it. So feel free to pause the video, try it on your own, see what kind of progress you make so that you know whether or not you need to do a lot more practice on this or just a little bit more practice on this, or where exactly you're at. So we want to do 8m squared and -6. We want to multiply those together and get -48. We want to say what multiplies to get -48 that adds to get 13. So 1 and 48, 2 and 24, 3 and 16. 3 and 16 are 13 apart, which is good because since I'm multiplying to get a negative, I need to make one of these negative. Since I'm trying to add and get positive 13, the positive number needs to be the bigger number. So I'm going to do -3m and 16m. Now we're going to pull out what's in common. So 8m squared and -3m only have an m in common. 16m and -6 have a 2 in common, and it'll be positive. 8m squared and 16m have an 8m in common. -3m and -6 have a -3 in common. If I double check, 8m times m is 8m squared, 8m times 2 is 16m, -3 times m is -3m, -3 times 2 is -6. So my answers are 8m minus 3 and m plus 2. Finally, this one is for all the marbles. There's not actually any marbles involved. We're going to do our box. Feel free to pause and try to do it yourself if you haven't already. We're going to put 7n squared here at -8 is going to go there. Let me try that again. And we're going to say 7 times -8 is -56, and we're going to try to figure out what multiplies to get negative 56 that adds to get negative 17. So 1 and 56, 2 goes into it because it's even. 3 does not go into it because 5 plus 6 is 11, and 11 is not divisible by 3. 4 should go into it 14 times. That's close if we were able to add. That would be 18. 6 doesn't go into it. 7 and 8, which when we add together is 15. The problem here is we've come up with all of our pairs. One of them is supposed to be negative, and none of these work. So that's where the rest of this, these instructions come into play. This is actually not factorable. And so it's my advice to you that if you are willing to put not factorable on a problem, I would write down all of the factor pairs to show your teacher that you really tried and you didn't just try to take the easy way out and write not factorable. Because I know for me personally as a teacher, if I just see someone write not factorable, especially if it actually was factorable, I'm just going to assume you're being lazy and didn't want to do the problem. And that is going to make me frustrated at you, which is fine, but it makes a person less willing to give partial credit when that happens. So, and in fact, just having an answer of not factorable means you wouldn't get any partial credit because you didn't do anything. You just said not factorable. So, off my soapbox, make extra sure by making a list of factor pairs before you just say that something is not factorable. So this is just one of the methods that you can use. I actually made a video of this last year at this time that goes over a different way of doing it called slide and divide. So I will attempt to link that at the end of the video as a suggested video as well, so that you can see the difference between the two. This is the box method. The other method is slide and divide. They basically ask you to do something very similar. Either way, you're going to have to end up coming up with what multiplies to get one number that adds to get another number. It's just that the end result, like the next step, is different between the two. So feel free, if you don't like this method, to look at that other video, decide if you like that better. And then the key thing is you got to figure out a way to do it. So if that means doing guess and check, fine. If that means doing the box method, fine. If that means slide and divide, fine. Do it whatever way you need to. Just make sure you come up with a way you can do it. Thanks for watching.
If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching.